So welcome to 4K's private tuition. In this video we're going to do combustion analysis. This is very important. It involves stoichiometry, and you should be able to determine the molecular formula of a compound given combustion data. So this is very important for you to be able to do. So we are going to do this by means of a question. We have a question here that says 20 cubic centimeters of an unknown hydrocarbon of the formula CXHY was mixed with 80 cubic centimeters and excess of oxygen in a graduated tube. A spark was applied to the resulting mixture of gases. A spark was applied and the resulting mixture of gases was allowed to cool to room temperature. 60 cubic centimeters of gas was left. When this gas was exposed to sodium hydroxide solution, the mixture fell to 40 cubic centimeters. So you are asked here to determine the formula of the hydrocarbon CXHY. So you must be able to know the general equation for the combustion of a hydrocarbon. The general equation for the combustion of a hydrocarbon, which is CXHY plus the ratio of oxygen there is going to be X plus Y over 4. And the ratio of carbon dioxide produced is X plus Y over 2 for water. So this general equation, you must know it by heart. So we are told here that after combustion, the resulting mixture of gases was allowed to cool and 60 cubic centimeters was left. So we are going to eliminate water here because water is going to be in liquid form. So the 60 cubic centimeters of the gases that are left must be the excess oxygen, the unused oxygen, and the carbon dioxide gas which is produced after combustion. And we are told that when this mixture of gases, the 60 cubic centimeters was passed to sodium hydroxide solution, which absorbs carbon dioxide, the remainder or the volume fell to 40 cubic centimeters. That means that we can find the amount of carbon dioxide that was there, since we know the initial amount there and the resultant volume. So back to this. So this is important information to take away from this. After cooling, we have unused oxygen and carbon dioxide, and after passing through the sodium hydroxide, we remove the carbon dioxide and we remain with unused oxygen. So let's try to answer this. The volume of the hydrocarbon that we used to begin with was 20 cubic centimeters. And what is the volume of the carbon dioxide? So the volume of the carbon dioxide here is going to be equal to your 60 cubic centimeters minus the remainder after passing through sodium hydroxide, which absorbed your carbon dioxide, and therefore the volume of the carbon dioxide is equal to 20 cubic centimeters. And the volume of the oxygen that was used, that is unused, that is the remainder after passing through your sodium hydroxide solution, it's 40 cubic centimeters. And the volume of the oxygen used is equal to the excess amount of 80 cubic centimeters minus the unused of volume. So we have 80 minus 40 and we get 40 cubic centimeters. So once you have all these ratios, then you can turn them into molar ratios. This is provided all the gases are under the same conditions. So we see here that all the gases are under the same conditions. So you can turn this into molar volumes. So let's see now how you can determine the molecular formula of the compound. So we are told here with 20 cubic centimeters, we are determined here that we had 40 cubic centimeters of oxygen that was used to produce 20 cubic centimeters of carbon dioxide. So if we look at the ratio of the hydrocarbon to the carbon dioxide produced, we see that it's a 20 cubic centimeters to 20 cubic centimeters, 1:1. So that means our X is equal to 1. And if we look here at the volume of the hydrocarbon to the oxygen that was used, we see that we have 20 cubic centimeters to 40 cubic centimeters, and that turns into a ratio of 1:2. So that means our X plus Y over 4 is equal to 2. And we can simplify that into a linear equation and substitute for X. We already know X is equal to 1, and if we substitute, we can find the value of Y, giving us Y is equal to 4. So the formula here is C1H4, which is methane. So this is how you can use combustion data to determine the molecular formula of a hydrocarbon. Meet you in another video.